For section 3.5, we're going to talk about slopes of lines. So moving back into a more algebraic topic here. Remember, slope of a line is rise over run. The rise is the difference in the y values, how much you go up or down. And run is the difference in your x values, how much you go side to side. Remember, down is negative and left is negative, up is positive and right is positive. So we can use rise over run to find slope, or we can use the slope formula here, which is y2 minus y1 over x2 minus x1. So if you're given 2 points, you can use the values out of those to plug into that formula. So the 1s and the 2s just mean out of the first point or out of the second point. So for some examples here, it says use the slope formula to determine the slope of each line. So I'm going to do rise over run and the slope formula. So here, we're going to go up and we're going to go over. This is 2, 3, and this is 6, 4. So we're going from 3 up to 4, so that's going up 1. And then we're going on the x-axis, we're going from 2 over to 6, so that's moving over 4. So rise over run, rise is 1, run is 4. Now, using the slope formula of y2 minus y1 over x2 minus x1, I'm going to pick this as my number 1 point, and this is my number 2 point. So y out of 2 is 4, minus y out of 1 is 3, and x out of 2 is 6, minus x out of 1 is 2. So when I do the work here, 4 minus 3 is 1, 6 minus 2 is 4. So if you're given a graph, you can do rise over run. If you're given just 2 ordered pairs, you have to use the slope formula. And it's positive, and we know it's positive just by looking at it because the line is going uphill when we look at it from left to right. So we know it should have a positive answer. This one, I'm going to pick these 2 points here, 2, 3, and 2, 4. So this is going to be point number 1, and this is going to be point number 2. So y out of my second point is 4, minus y out of the first point is 3, and x out of the second point is 2, minus x out of the first is 2 as well. So I get 1 over 0. I cannot do that. I can't take 1 and put it into 0 groups. So when 0 is on the bottom, your slope is what's called undefined. So anytime you have a vertical line that's straight up and down, the slope is undefined. You don't need to show your work. You just need to know and remember that. All right, for this one, I know it's going to be a negative slope because it's going downhill. So I'm going to pick the 2 points. This is going to be point number 1, and this is going to be my point number 2. You can pick any 2 points on that line. You don't need to use those exact 2. You're going to get the same answer, whichever 2 points you use. So y for my second point is negative 2, minus y for my first is 0, and then x for my first, or x for my second is 1, minus x for my first is 0. And when I simplify, I get negative 2 over 1, which is negative 2. So we knew it was negative just by looking at it because it's going downhill from left to right. And then our last one here is a horizontal line. I am going to pick this point here, which is negative 2, negative 2. Oops. Negative 2, negative 2. And this point over here, which is 2, negative 2. So this is going to be point number 1 and point number 2. So y out of my second point is negative 2 minus y out of my first is negative 2. So that's going to turn into a plus. Minus a negative is plus. So negative 2 plus 2 is going to give me 0. On the bottom, x for my second point is 2 minus x for my first is negative 2. So that's going to turn into a plus as well. So I have 2 plus 2, that's 4. 0 divided by 4 is going to be 0. So the slope of a horizontal line is always going to be 0. All right. Tony is driving from Dallas, Texas to Atlanta, Georgia. At 3 p.m., he is 180 miles from Dallas. At 5:30 p.m., he is 330 miles from Dallas. Graph the line that represents Tony's distance from Dallas at a given time. Find and interpret the slope of this line. So I can do rise over run since I already put the graph on here for you instead of taking the time to draw that out. We can do rise over run, or we can use the slope formula. But since we have a picture, let's do rise over run. So we're going to go up, and then we're going to have to go over. So my y value is 180, and I went up to 330. So that would be 150 up. And then I'm going over from 3 to 5.5. So from 3 to 5.5 is 2.5. So my slope, my rise over run, is 150 over 2.5. And when I divide that out, I get 60. So the slope of this line is 60. But they want to know, interpret the slope. What does that slope represent? So my 150, is the y going up here, and y is our distance in miles. So this was miles. And then going over, the x values is time in hours. So this is hours. So we use those labels here, 60 miles per hour. So the slope here is given his speed. How fast is he driving? All right, a couple of theorems here. Parallel line theorem says that in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. So if you have two straight up and down lines, those are automatically parallel. If you have lines that are slanted, we have to find the slope of those, and if they're the same, then we prove that they're parallel. For perpendicular lines, non-vertical, they're perpendicular if and only if the product of their slope is 1. So if we can multiply the two slopes together, we get -1. The other thing that I can say is that they're opposite reciprocals. So for instance, if I have one is a slope of 2/3, then the slope of the perpendicular line would be -3/2. You flip it, and one is positive, one is negative. That's also something you can look at. And then if we multiplied that together, we would get -6/6, which is -1, which is what they talk about in the theorem. And then vertical and horizontal lines are automatically perpendicular. So straight up and down, straight across, horizontally, those are automatically perpendicular. So a slope of 0 and a slope of undefined. Okay, so we have to graph these lines and use slopes to determine whether the lines are parallel, perpendicular, or neither. So we have A and B, and their points are 2, 1, and 1, 5. So over 2, up 1, and over 1, up 5. So the slope of this line is up 4 and back 1, so that's -1. So 4 over -1 would simplify down to -4. So that's line AB. And then CD is over 4 and up 2, and over 5 and down -2. And my rise over my run, I'm going to go up 1, 2, 3, 4, up 4, and back 1 as well. So that simplifies to -4. So they have the same slope, so they are parallel lines. For this one, we have ST and UV with the given points. So let's do ST here is -2 and +2. And T is 5, -1, so over 5 and down 1. So up and back, 1, 2, 3. So I went up 3, and then 1, 2, 3, 4, 5, 6, 7, back 7. So -3, 7. So ST was rise 3, run -7. So now let's do UV. their line is, or their points are 3, 4, over 3, up 4, and over -1 and down 4. So these lines cross, so they're definitely not going to be parallel. So let's find the rise over the run. So up and over. So 1, 2, 3, 4, 5, 6, 7, 8. Up 8 and back 4. So 8 and -4, that would simplify to -2. So 3, -7, which is the same thing as -3/7. These slopes are not the same, and they are not opposite reciprocals. I can't multiply them together and get -1. So these are going to be neither. They're not parallel and they're not perpendicular. They're just two lines that cross. And then for our last one here, we have FG and HJ. So FG is over 1, up 1, and over 2, up 2. So that is up 1, over 1. Which is 1. So that has a slope of 1. Now, H is over 2, up 1, and J is over 1, up 2. And that rise is 1, and then we go back 1. HJ, we went up 1, and we went back 1. That is -1. So if I multiply these two numbers together, I get -1, which is what the perpendicular line theorem said, is if we multiply them together, we can prove that they are perpendicular. So those lines are perpendicular. Upside down T is the symbol for perpendicular.